Michael, the floor is yours.
Morning, everybody. And I know some of you very well from previous projects, so I hope you're all keeping well. I'm currently working on the ENERFUND project with Suzanne. We're in the early stages of it, but we did some interesting work in the EPISCOPE project, which has just finished, where we developed an EPC mapping application. So just the EPC status in Ireland, we have 1.65 million dwellings, about 625,000 now have EPCs, 100,000 additional new EPCs for dwellings are published per year. Our national EPC statistics are updated monthly by the Sustainable Energy Authority of Ireland. We have a national EPC research tool that's available online, produced by the same authority, SCAI, and this is updated daily and it's free to download. So it's available to researchers throughout the country to use, and we ourselves have used it. So on the EPISCOPE project, EPISCOPE had included pilot actions from 16 member states to track the refurbishment of housing stocks. So the key questions were, what proportion of your housing stock has been refurbished to date? What proportion of the dwellings are getting energy upgrades each year? And if we're going to miss our 2020, 2030 targets, what gaps are there and how do we address these gaps with policy alterations, etc.? So in the Irish EPISCOPE project, we had three main sources in order to find what's the current state of our stock. One was we used the term BER, which is Building Energy Rating in Ireland, which is the same as an EPC. So that's the national research tool. That was one of our sources of data. The second was we got data from national retrofit programs. So these are grant schemes, etc., to give people financial assistance to do energy upgrades. The same for local authorities. So these are all recorded schemes. And what we also did was we did a field survey, so which I'll explain in a moment. So we used all of these data sources. We selected the housing stock of the north side of Dublin City, which for our pilot action survey in terms of tracking the rate of refurbishment of the stock. And this would ultimately give us data on the percentage of stock refurbished to date and the annual rate of refurbishment. So all 16 partners in EPISCOPE pretty much went through the same methodology or different approaches, but all had to come up with the same types of analysis. And within
Michael, can I ask you to speak a little bit louder or closer to the microphone?
Okay. Hopefully
yes, much better.
Okay.
Yep. Thank you.
Right.
Good.
So within EPISCOPE, there were a range of standard reporting formats produced for the results, which comes in these kind of formats, which are fine for partners who are on the projects. They understand them, but they're a little bit difficult, and even the charts themselves you have to almost explain them to an audience. So we decided that it would be very interesting right at the start of the project if we could map EPC data to show this type of information in a more visual way. So alongside our core analysis, we developed a mapping application of EPC data. So the north side of Dublin City, again, the main statistics are there with the population and the number of dwellings. And it's also broken down when we're looking at it from a mapping point of view. It has 1,242 small areas, which are geographical areas of up to 200 dwellings, and it's the lowest level, lowest geographical area for national statistics. So we went through a process in order to actually get the EPC data. So this was a key process for us. So we approached the Sustainable Energy Authority of Ireland, who were extremely cooperative through the whole process. We gave them a list of 37,000 addresses that have EPCs. We were able to get this from the National EPC database ourselves. So we then gave them the list. They came back to us with the list of addresses, and to this we attached, these were the exact addresses, we attached what are called, through our Geo-directory partner, the small area codes and the electoral division codes. SCAI then came to us and they gave us the data for all of these addresses, but they removed the actual address of the house or the apartment in terms of the street number and the street name and number. But they included then was the small area codes and the electoral division codes and all of the EPC data for the 37,000 addresses. So the data came back in this format, and this enabled us then to develop our mapping applications. So the data delivery process took about 6 months to complete from start to finish, so that everybody was happy in terms of that we had anonymized the data sufficiently and that all the processes were robust and transparent. So this is our map of the north side of Dublin City, showing the EPC ratings. And we developed about 20 different maps. As it happens, the average EPC is a D2 for the north side of the city, which is the same in fact for the entire country. So using the tool, just for further reference, we have developed a quick guide in terms of developing the tool, and the mapping tool is available at this particular address. So in order to get started on the mapping tool, again for later reference, you just click on a box at the top right-hand corner of the screen. You select the EPC predominant layer, and in this case, where you see the predominant layer, we have a range of different mapping layers, like the building age, the wall type, the wall U values. Where you see an asterisk beside the description of the layer, that actually means when you pan in much more closely, pies will appear. So while the predominant type, for example, in this case, might be built between 1978 and 1982, the darker green, if there are other dwellings in that same small area from different building ages, then they'll be represented in the pie. So it'll tell you whether there's a mix of types or whether there's just one type only. And also, if you click into the small area, the actual counts will appear. In this case, we're showing the wall types. So the counts of the wall types. So while the color shown is for the predominant type, the counts of all of the types within that small area are shown as well. So I'm just going to go through an example of a number of the different maps that we've produced. This one is building age. So closer to the center of the city, you basically have the darker blue colors, which were built around the turn of the century, 1900 up to 1930s. And then as you move kind of north on the map, and then you're getting out to areas that were built in the 50s and 60s, and on the fringe, you'll see stuff that was built more times around 2005 onwards. And actually, the center of the city, the docks area, was built 2005 onwards. So it makes a lot of sense. This here is the next map I'm showing are the wall types. So this starts to get interesting when we're looking at building typologies and ideas for retrofitting measures. So again, we have identified all the main wall types. And one of the things I can't show you here, but you can pan in and you can decrease the transparency level, so you can actually see the exact streets related to these wall types as well. So here's an example where we're panning in. So as I was just talking about, here's where we pan into specific streets. And again, these pies will appear because it'll tell you that whether there is a single wall type in a particular small area or a mix of wall types. We are actually looking at doing a newer version of this that we will actually bring it to street level. But that's a new piece of work we're looking at the moment. What we also developed were, again, from the EPC database, we have a map which is showing us the wall insulation levels in terms of U values. So what we have done in this case is we have followed the EPC color coding scheme, where red obviously is the poorest performance and green is the best performance, and we've picked here 4 bands for ranges of wall U values. So in the case of red, it would be uninsulated, absolutely uninsulated walls, U value greater than 1.64, and poorly insulated walls would be the kind of orange-brown color, which has a U value of greater than 0.6 but less than 1.64. So straight away, what this map does visually, very quickly, gives an impression of what is the state of the insulation of the walls of our housing stock. And obviously, it's not too good at the moment when we're looking at where we need to get to with regard to 2020, 30 and 2050 targets. So this map very much gives us a current status indicator of the insulation levels of our walls. So we have done exactly the same kind of methodology has been done in terms of roof insulation levels. And we did the same, and here we have identified the primary heating types. So obviously most of the city is supplied by natural gas. in the city centre areas, particularly for apartment blocks, electricity would be the dominant fuel that is used. We've also a map here of the window U values, so we have again gone with the same color coding approach. And primary heating efficiency is the next map I'm showing. So this one shows where we've picked efficiency bands just to give an indicator of the status of the heating systems. And this map is tells a bit of a sad tale. And this map shows heating controls, and basically where red indicates that we have no thermostatic control of space heating. This would be backed up by the field survey we carried out, where we found lots of people had replaced old broken boilers with new condensing boilers, but in most cases they hadn't upgraded their heating controls at all, so they literally had a simple timer to turn the heating system on and off, with no thermostats controlling the boilers. So when we've shown this at various forums, it has visually it gives a stark message, and the message comes over loud and clear, which is what we were hoping to do through the mapping tool. This is another map we developed, which shows building typologies by age band, and the areas in white would be where there is insignificant data for that particular time period. So again, this goes back to some of the work we did in the Tabula project. This is the last map I'm going to show. So this is a fuel poverty map, and in this map here, what we have done is we have combined the EPC data for E, F, and G bands, along with the income data sets, where we have the 3 lowest income deciles. So, and basically, we are showing where these 2 data sets are overlap. Then you have areas that have a higher risk of fuel poverty. This was not a robust study, but it does just show what can be done when you start to combine EPC data sets with other data sets and map the results. So I would quickly just a couple of slides here on ENERFUND just at the end of my presentation. ENERFUND project has just started. It will include a significant mapping element. It will address the need to identify retrofitting opportunities and identify funding sources and incentives. The goal is ENERFUND is a tool that will rate and score deep renovation opportunities. It will be used on a methodology to be developed with on a set of parameters such as EPC data, a number of certified installers, government schemes, etc. It will provide a rating for deep renovation opportunities so that funding institutes can provide targeted loans, retrofit companies can identify sound opportunities, municipalities can promote targeted incentives, and the public's trust for retrofitting will be enhanced. So that concludes my presentation. The main project leader on the ENERFUND project is Aleksandra Arcipowska, and of course Suzanne is also working on the same project. So that is the end of my presentation. Thanks for listening to me.